Hi everyone, welcome to our geography project presentation. Today our group is going to summarize our observation from our recent fieldwork where we investigated different slope engineering measures used to protect human activities.
For our project, we chose to study two different slopes. At Site 1, we recorded four main measures: a retaining wall, weep post, a drainage channel, and a boulder fence. At Site 2, we observed a completely different combination: a gabion wall, soil nails, a drainage channel, and a shotcrete cover.
When we compared their appearances, we noticed major differences. The retaining wall at Site 1 is made of solid concrete, but it had a lot of bland, faded colors. We actually counted about 1 to 3 visible cracks on it. On the other hand, the gabion wall at Site 2 is made of rocks trapped in metal wire cages. However, it showed much more serious wear, with around 7 to 9 visible damage or disorientants.
We also looked at the surface treatment. Site 2 used a rough gray shotcrete to completely seal off the surface of the slope, while Site 1 left natural environment more open but added a metal boulder fence on the bottom to catch any falling rocks.
So why did engineers choose these specific measures for each site? It all comes down to the surrounding land use and environment. Site 1 is right next to a busy residential and transportational area. A solid concrete retaining wall and a boulder fence are perfect here because they provide strong, rigid protection to stop rocks from hitting cars or houses immediately.
For Site 2, the environment involves transportation, but also has a large natural mountain nearby. Because the slope is likely much larger and deeper, engineers use soil nail to drill deep into the bedrock to tie the slope together, and covered it with shotcrete to cover rainwater, to stop rainwater from soaking into the soil and causing a landslide.
Now let's evaluate how effective these measures are in protecting human activities using our own on-site data. At both sites, the drainage channels were working well to divert rainwater away. At Site 1, our data show absolutely no deformation and no dirt or blockages. In the weep post, meaning water can escape safely without building up dangerous pressure behind the wall.
However, we have to look at the warning signs too. Site 1 had 1 to 3 cracks, and Site 2 had a high number of 7 to 9 structural damages on the gabion wall. Along with the mild deformation, this data tells us that while the measures are successfully protecting the roads and houses right now, they are under a lot of stress and will need maintenance soon to stay safe.
In conclusion, both sites use a clever mix of engineering measures tailored to their specific environments. Even though some structures are showing signs of age, they are still doing a great job keeping Hong Kong's road and residents safe. Thank you for watching our video.